going to start off with section 2.2 on page 33. It talks about separable equations. What separable equations are, they're simply calculus problems. They look either like this or like this, in which you could separate the function of y with dy and the function of x with dx, and you could integrate. This is pretty much literally what you did in your calculus courses, and it's just a review of that. So you need a bit of techniques of integration, not much really in this case. So here I look at this. Well, this is dy, in this case dx, equals negative y squared the sine of x. So we're trying to solve for y. If I divide by y squared and cross multiply, there, I was able to get y with its dy and x with the dx. This is y to the negative 2. Add 1 to the power, divide by that. That's simply negative 1 over y equaling. And here, if I want to integrate this, the integral of negative is minus a negative cosine. So that makes it a positive. So I could say 1 over y equals negative the cosine of x plus c. And I could say the reciprocal of this side is 1 over c minus the cosine of x, or negative cosine of x plus c. Either way. On number 4, and these are on page 38. On number 4, I notice that if I write this as x dy dx is going to equal 1 minus y squared to the 1/2. So if I swap those, divide, cross multiply, I'll be getting x dy equal, and if I get dy over the square root of 1 minus y squared will equal dx over x. If I integrate, well, I know this is the inverse sine of y, and this is natural log of absolute value of x plus c, and I could say y equal the sine of natural log of absolute value of x plus c. And here similarly, if I proceed, cross multiply, 1 plus y squared dy equals x squared dx, and if I integrate, I'll be looking at y plus y cubed divided by 3 equals x cubed over 3 plus c. Since I can't solve for y in this case, I would simply say that's the equation. So this is more looking like this. I get everything on one side 0. On the other side, say, look, take a derivative of that, guess what you'll get. And that's how differential equations normally look like. I have a few more to go. I'd like to look at problem number 10. Here they say we're going to just focus on part A. It says find the solution of the initial value problem. So here you're going to find C. That's the only difference. So this is dy dx. That is 1 minus 2x over y. If I cross multiply, y dy equals 1 minus 2x dx. If I integrate, I'm looking at y squared over 2 equaling x minus x squared plus c. And here I'm going to show you, I want to get this out of the way since this is something that's never going to go away. So I'm going to do this 2 different ways. Okay, I went a bit too far here. So here I could say, case 1, I could say y squared equals 2x minus 2x squared plus 2c, this 2. And I could say y equal plus or minus the square root of 2x minus 2x squared plus 2c. All what I have to do is find c. Y of 1 is plus or minus the square root of 2 minus 2 plus 2c. And that equals a negative 2. The only way this will have a solution, the only way a solution would exist, if I have a negative equaling a negative, this way I'll get the square root when I divide to equal a positive 2. A square root can never equal square both sides, I'll get a 4. I will say c equal 2. And guess what? If I throw a 2 in there, I could say that the solution to this problem is that y equal, and what did we agree on? Negative the square root of 2x minus 2x squared. If you put a 2 in there, that would be a 4. I could say y equal negative the square root of 2x squared minus, oh man, third time would be a charm, 2x minus 2x squared plus 2 times 2 is a 4. Now, this is going to come up a lot, and I want to make sure we clear that out, so we're not going to be asking this every time. What happened? Does the C pick that up? The second case I want to tackle this problem, I would like to look at this problem in the sense of, from this step, when I multiply by 2, I'm going to say, you know what? Y squared is going to equal 2x minus 2x squared plus c. What happened to the 2? C absorbs it. C plus 2 is c. C divided by 2 is c. And I'm going to say y equal plus or minus the square root of 2x minus 2x squared plus c. Y of 1 is going to equal plus or minus the square root of 2 times 1 minus 2 times 1 squared plus c. And that is a negative 2. The only way this will have a solution, if I have negative square root of c equal negative 2, and if I square both sides, I'll get c to be 4. There it is. So, do we agree that there is no difference whether you tag on the number or you just say it's c? If you say it's c, it's going to save you a lot of work. Well, not a lot of work, some work, but it's much easier. So that's how I'm going to stick with the problems from now on. 2 more problems to go, 12 and 16. Well, here I'm going to say the r over r squared equals d theta over theta. If I integrate, negative 1 over r equals natural log of theta plus c. So I could figure out what c is. I could say, if you throw in a 1, that's natural log of 1 plus c, and that equals negative 1. This is a 2. So 0 plus c equal negative 1/2, c equals negative 1/2. So I could say at this stage, negative 1 over r equal natural log of theta minus 1/2, and I could say 1 over r equal negative natural log of theta plus 1/2. And if I take the reciprocal of this side, that would be the reciprocal of this side. I could say 1/2 minus natural log of theta. The back of the book might clear the fractions and say that is a 2 over 1 minus twice natural log of absolute value. It makes no difference. And 16 is the last problem. And there's the homework. So let's look at 16. If I really want to separate those, well, they're already separated. I could say that cosine of 3y dy is going to equal negative the sine of 2x dx. If I integrate, I could get the sine of 3y over 3 equals the cosine of 2x over 2 plus c, right? And I could say sine of 3y equals 3 the cosine of 2x over 2 plus c. I could say the sine of, now, if I throw a pi over 2n for x, I will get the y to equal pi over 3. So this will be a pi over 3, and there will be a 3 times there equal 3 over 2 the cosine of 2 pi over 2 plus c. So I could say that sine of pi is 0. That is negative 3 halves plus c. I could say c is 3 halves. And that would mean that the sine of 3y, I'm talking about this, equals 3 halves the cosine of 2x plus 3 halves. So I could say that 3y equals, I forgot the equal sign, same thing, right? Equals the inverse sine or the arc sine of 3 halves the cosine of 2x plus 3 halves, and y would equal 1/3 the arc sine of 3 halves the cosine of 2x plus 3 halves. And there's the homework. Right? A nice section.